Hello everybody, it's time to do some C again, and in this video I'm planning to code a Starfield animation. I hope you can see it here. This is a Wikipedia page, which this looks very nice. I want to do something like this, but I want to do it in C. And that is the plan or the goal of this video. Let's see how this was done in Wikipedia. Is there any article linked with that? Oh, they even have rotating star fields. Crazy. Okay. That's interesting. They even upload source code here. It's MATLAB code. Interesting. Let's see if we can do it in C. I haven't coded C in like half a year, so I'm not sure if I even remember all the syntax and all of that. So this is really picking up the skills almost from scratch again. I really have really poor short-term memory. So I think that the first thing that we're going to do is include SDL2, SDL.h, it was something like that. Let's save the file, starfield.c. Okay, and let's also include math.h, just as a preliminary course. Maybe we will need some math. Oh no, let's delete it. Let's forget about it. We will import everything when we need it. Let's create a main method. Oh god. Let's create a main method. And let me just place my keyboard on a mat so the sounds are a bit muted when I type. Probably sounds better for you. Okay. Now I'm prepared. Okay. The first thing that I'm going to do, since I am really poor, since my C skills are very poor, let's make it a Hello World application. And I think I also have to zoom in for you. Let me make this a bit bigger. And bring down this pane here. Okay, this should definitely be big enough for the video. All right, let's do a printf hello world with a new line at the end. And let's go over here and do the following. Let's compile that. Starfield application, the output is going to be Starfield, and that compiled. So let's try to execute that. And we got a hello world. Okay, that's already a good start. That's a good start. Whew, now, what do we do now? Now the next step is to create a graphical user interface, and that is going to be a window that the SDL library instantiates. So let's look up how all of that is done. I completely forgot, but maybe I'll quickly remember. Let's see. I'll pull up the SDL2 documentation. I know there's also SDL3 already. So far I have worked with SDL2, so that's what I choose. There's no real reason to pick either of them. If you're just rendering just so simple stuff on the screen, it doesn't matter. So if you're wondering, do I need SDL2 or SDL3 as a graphics library? If you have to ask that question, probably it doesn't matter. Okay, what do I now need? Create window, maybe? Create window. Let's see. All of that is SDL3. SDL2, create window. Oh, there's a page, and I've even visited it before. And we can use this function here, SDL, create window. Oh, good God. I really forgot all of that. Let's copy it and see. I think we also used to call some init function before. I think the zoom factor is a bit too large. This one is better. Okay. So we do create a window, as you can see. It's a bit messy right now, but the window creation method is accepting a title, it's accepting X and Y coordinates and a width and a height and some flags. Yes. So let's use that function to do the following. We're creating a window pointer using SDL create window. Then let me just delete all of that junk code here. And the window pointer should of course be called p window because it's a pointer. Now we're passing a string title. Let me just call it Starfield. Then let's just pass random numbers. So X and Y are 50 and 50. And the width and height are 400 by 400. And then flags are 0. And I think if I compile this application, we will get a compilation error because C doesn't know, or the C compiler doesn't know what to do with the SDL library. Yeah, undefined reference to SDL create window. So it can't find this method defined anywhere. And for that, we need to find out how to install SDL, I think. Install it. And there should be compilation commands on this installation page somewhere. Yes. Once you have the library installed, which I have already done, you can do it like... I think I just did sudo apt get or sudo apt install SDL2 or something like that. But yeah, you can follow the installation commands here on the installation page. And to compile the SDL code, you need to attach those SDL flags. So you can check whether it's installed by calling SDL2 config. Let's do that. And as you can see, there's a usage printout, which indicates that something is installed. So on my end, it's installed. So let's copy all of those flags and just see what those evaluate to. And as you can see, those are compilation flags that are used. And now we can use those compilation flags in the cc command or gcc or whatever C compiler you use to compile the application. So I'm doing cc starfield.c, which is the C application. I'm compiling it to output file Starfield, and I'm attaching the SDL2 compilation commands. So let's go, and that's it. Let's execute, and nothing happened, of course, as expected, because I think we need an SDL delay. Let's do 5 seconds, and this will still not work because I think we have to initialize SDL before. So let me recompile and re-execute. Oh, and I do have a window. It just started on a different screen. There it is. That's interesting. Why did I not need SDL init? SDL init. SDL2 init. Let me look up what that is for. Okay, I will still call it. I always thought that we have to initialize SDL. That's very interesting. Let me just do that. And which flags does it accept? Let me just check that as well. The initialization flags are, they indicate what kind of systems you want to use in SDL. There is a timer, there's an audio subsystem, video subsystem, joystick, haptic, game controller, events, everything. Yeah, We just need the video system, since that's what we are, since we're just rendering graphics. So SDL init video, SDL init, SDL init video, there it is. By the way, if you were wondering about those suggestions in Vim, they are coming from a coming from a plugin that's called ALE, ALE. So if you want, you can look that up, but you don't really need it. It's just for fun. It's nice that it can highlight syntax errors occasionally. All right. So P window is created. Let's launch. No. It's still not good enough for this video because we are passing a fixed X and Y coordinate here, but I want it to be rendered on the center of the screen, so we're using SDL window pause centered. Let's do that. SDL window pause centered. And same thing here, SDL window pause centered. Let's see what happens now. I'm recompiling that and executing it. And there it is, this time on the center of the screen that I'm working on, which is awesome. And the application is quitting after 5 seconds because nothing is happening. So the code is initializing the video component of SDL. It's printing hello world. Then we're creating a window. And then we're introducing a delay to keep the window alive for just 5 seconds. And to draw on that window, on the black surface of that window, we need to have access to that surface, and that can be done via SDL Surface, obviously, and we use a pointer to retrieve that. And I think there was something like get surface or something. SDL, let's look that up. SDL surface. SDL get window surface, something like that maybe. Get window surface, yes, and then we pass the P window. Let's try to compile that. If that works, that's just pure luck. Seem to have worked. But let's look it up in the documentation. Get window surface, there it is. And we pass as input the pointer to the window. Yeah, so that's where it's coming from. So I'm not making that stuff up on my own here. By the way, I often get comments asking why I'm breathing so much. That's just pure bad speaking skills. I don't have any breathing problems. It's just I speak and then I run out of breath and then I inhale a full lung. Yeah. That's a bad habit. Anyways. Good God. You probably know the sort of things that when you start thinking about them, you become even more aware of them. For example, don't think of the top of your head itching right now. Or think of the top of your head itching right now. It's going to itch. And similarly, if people comment that I breathe oddly during the videos, what will I do? I will breathe even more oddly. So it doesn't help. It doesn't really help. I should attend some breathing training. All right. And what is the next thing that we're going to do? We have now access to the surface, and now I think we can create a rectangle. SDL create create, no, not a renderer. Maybe SDL draw rectangle. Draw, nope. Fill rectangle, it was fill rectangle, but let's just look it up for the completeness. Yes, SDL FillRect. It accepts as input a destination surface, which we want to draw on, then a rectangle, and then a color. So let's do FillRect. We pass the destination surface, a rectangle, and then the destination color. And the color is going to be color white. Don't worry, we're defining what white is here. Define color white, and it is FF. I think that's it. And then the rectangle is going to be a pointer, technically. So let's create that. I think in the past I did the following. I created an SDL rectangle structure here, rect, and that is equal to, and I think then we have to somehow instantiate that SDL rect. Let's look that up. A rectangle with the origin at the upper left corner. And the rectangle is a structure that accepts or that contains the fields x, y, width, and height. Okay. And I think we can now just pass x, y, width, and height, and close that, and that is the instantiated structure, I think. And now we can refer to that rectangle in this FillRect method using this ampersand icon, which refers then to the address of the rectangle, which is the same as the pointer, pretty much. So let's compile that and see if we have a rectangle. There's no rectangle. Why is there no rectangle? I mean, it's defined there. It's white. Okay. I think that we have to update SDL. Update Windows Surface, and this takes as input the window. Let's see. And there it is. This is our rectangle. Yeah, so what SDL fill rectangle does is it fills the rectangle in memory. Of course, the rectangle is, SDL has no concept of graphics. Or I mean, a computer has no concept of graphics. And when you create a rectangle, you define a structure here, and fill rectangle will just fill values in memory, but the memory values don't yet reflect what is displayed on the screen. So all of that memory has to be somehow moved and displayed in your in the graphics. Oh, how do I put it? In the graphics memory, the memory has to somehow be copied over or processed in the graphics memory. No, the memory that is the working memory of the C application somehow has to be transferred to the graphics memory, which then visualizes what is displayed on the screen. Maybe that is approximating somehow how it's really working. Okay, so let's have a look at the application. That is it. Starfield, fine. Okay, so now we have a fill rectangle method, and we have a delay here. And all of that is fine. So what I would like to do next is eliminate the delay and accept the user pressing this exit icon, because right now it's completely unresponsive because it's just delaying by 5 seconds and ignoring everything that happens, or everything that the user inputs in between. So let's have a look at how to do that. SDL exit or SDL2 event loop. That's what we need. We need to poll events. Yes. While game is still running, we poll events. And then we update the state of what is happening. Yeah. Okay. So we are eliminating now the delay, and we're keeping the application alive forever until the user exits the application. So let's do the following. While simulation running, the Starfield simulation. While the simulation is running, we are creating this SDL event. We are referring to an SDL event here, and we're filling the value in SDL poll event, and we're passing the address of the event such that the event value is set here. And then inside this nested while loop, we are checking which event happened. And if the event is equal, this is just pseudocode right now. If the event is an exit event, I have no idea if that syntax is correct. I would bet $1 million that it's not. If the event is an exit event, then we do the following. We quit the application. Something like this. SDL quit. Or we just, no, even simpler, we just set simulation running to false. False doesn't exist, so we set it to 0. False doesn't exist in C. Then what do we do now? We are checking. Okay, the nested while loop seems to be correct. That is fine. We don't need it to run at maximum CPU power, so we can just introduce a small delay also to limit the frame rate here. Maybe 50 milliseconds. And then what do we do now? What do we do? We have to create the simulation running variable, of course. It's running at first, so that variable is 1. And now let's implement proper event checking. So let's see how that is done in SDL. There's the SDL event. And I'm expecting, or I want to handle an exit event, or well, the user interaction where the user closes the window. So this is the event structure. Or union. What is the difference between union and structure? I have no idea. Here it says event structure. Okay. Seems to be a composite of many structures or something. So here's the SDL event. And I'm expecting some quit event, quit requested event. So we can access the event.quit. Maybe. Event.quit. And going back to the documentation, event.quit. So let's look up the quit event. And the type must be SDL quit. Dot type must be equal to SDL quit. Okay, let's see. I'm recompiling. The application stays active, and now I'm pressing the quit button in the top right corner now, and it's working. Awesome. So now I spent 25 minutes to generate a window that is closable. Awesome. And at least that's something. Does the minimizing even work? Seems to work. The maximizing, yeah, is buggy because we're not handling the graphics for the maximize in the code. But that's already very nice. So now we have a running event loop that keeps the application alive and checks for what happens on the user side. And now, as long as the user doesn't quit, we can update or next simulation step or something. We can generate the next simulation step next. So what do we do? Let's take the logic of creating the rectangle. Let's take it out of this method let's take it out of this main method and create a method next that calculates the next state of graphics. Let's put it like this. Oops. And in this next method right here, we are creating the rectangle that we also created before. We receive as input the SDL surface pointer p surface and the window as well. Is that really necessary? I don't probably we don't need to update the window in this method. Let's just do it after calling the next method. And yeah, for everybody who's not sure what I'm doing, the next method will compute every single frame. So we are going to create these stars as rectangles. Somehow, I have no idea yet how to do that. And then for every frame, we are computing how these stars should move. And that is being done in the next method. Or maybe it should be called simulation step, or maybe even more straightforward, move stars. Move stars, that sounds good. Move stars. Please like this video for my incredible user friendliness. Okay, now we have this move stars method in which we are creating in which we have still nothing to do with stars. We are creating a single rectangle and drawing it on the screen, but let's see if that still works. Of course it doesn't work because something is wrong and I'm not passing the surface into the method as an expected input parameter. So now it should work. Let's see. And there is our star. It's not moving yet, obviously. So how do we get that to move? We have to update the position somehow. Maybe we can... Oh my god. let me just do something stupid simple, something very, very stupid simple. It has nothing to do with the star animation. I just want to show you how to move rectangles on the screen. So I'm just passing an integer that is going to increase or increment over time. And let's just put that integer here and here as well. This is complete. This has nothing to do with the star, so we're going to take a different approach. But let's just add that here, and this is just going to be a simple counter that is going to increment with each frame. I++. Okay, that should be it. So something has happened, but it seems to have a... Oh, wow, that's weird. Why is it so laggy? Oh my god. And why is it linked to my mouse hovering over the screen? What? Okay, my mouse is not hovering over the surface of the starfield. Let's just hover it. And now the rectangle is moving? Why? What does it have to do with the mouse? No, this... This makes no sense at all to me. So it's even... The rectangle is even just moving if I move the mouse. Huh? One thing that we might have to do is... whenever the stars have moved, no, before the stars move, or at some point in time, we have to clear the screen. And I think, if I recall correctly, just let me look that up for a second. Someone recently on my YouTube channel commented how we can erase what's printed on the screen. What I did in the past was I just generated a big, large black rectangle and rendered it on the screen, which basically erased all the data. But someone commented somewhere in one of my videos. Wait. SDL renderer has a clear function. Yes, it has a clear function, but I think we are not using the renderer, and therefore we can't use the renderer's clear function. So let's discard that approach. Probably I'm wrong, but yeah. So let's create the erase rectangle. Well, let's make it simpler. Black rectangle. And that is going to start from 0 to 0. It's going for... now we have to pass the width and the height of the screen. And we don't yet have defined those globally. So let's just take the opportunity to do that. Define width, width is 900, and define height 600, and let's also define color black as this. Then after generating this black rectangle, I would like to do the following. I will use the FillRectangle method, just like this. With a black rectangle, color black, to erase the screen. Okay, so let's restart the application. And the rectangle is now moving because between each frame we are drawing a big black rectangle, and then We are drawing a new fresh white rectangle over it. I still just don't get why it's only working if I drag the mouse over the screen. This is seriously disturbing, and probably it has to do something with this event loop. While the simulation is running, we are polling event. I think I know it. Okay. Oh my God. It's really crazy when you are coding. Sometimes you are convinced that something is completely wrong with the computer, but it's still you. I was putting all this drawing logic right here, the rectangle stuff and the move star stuff, inside the while loop for polling events. And of course, as long as the mouse doesn't move over the screen or I don't type anything, no events are being processed. So we have to put all those graphics, all that graphic stuff outside of the event polling loop and inside the parent loop, which just checks if the simulation is running. So if the simulation is running, we update the graphics down here. And of course, if events are happening, for example, the quit event, then we are quitting the application, but we don't generate the graphics only when the poll event loop is running. Yeah, okay, so that must be the explanation. Let's restart the application. And we have a moving rectangle. Okay, now let's do that 1,000 more times and with some more logic, and then we have a Starfield actually. No, it's not that simple. We have to do some more logic here. But that is already quite nice. And by the way, guys, this is important. Please, everybody, I'm always really having a hard time when I'm thinking of videos to record. And sometimes I'm just sitting here for an hour recording something and then I completely discard the video because I'm completely unhappy with it and I don't like the result at all. And it's really hard to find ideas. And this time, this video, and I have to acknowledge that this video is triggered by someone who recently commented in one of my videos. Let me show you. Why does YouTube now want a verification that it's me? Please, let me just record this. Oh, God. Okay, forget about it. But someone commented that they really miss my C content, and that is basically the reason I'm recording this today. So please always open your mouth in the comments. Let me know your opinions. Give me feedback. All of that is vital to keep this channel alive, really. Because if I just sit here, record stuff, and nobody is telling me anything, or people are just well, I need to hear your voice, guys. I need to hear your voice. That's what makes it fun for me. Okay, so black rectangle, SDL fill rectangle, move stars. So we are moving stars here, and we can discard the concept of the counter that is passed externally. So let me just remove that. Okay, now we should only have a simple rectangle, right? And what we do now is we have to somehow model the stars. And a star in this concept is, and that's the question. What is a star in this application? What is a star in this application? A star consists of definitely coordinates, int x, y. Does it have a z coordinate? By the way, do you say Z or Z? I say Z. But if it's Z, please correct me. XYZ, XYZ? So that's the star structure. So it's just a point in space. Basically, we could also name this point. But since we're dealing with a star field, let's say star. So the application has a structure definition for a star. And then it would be useful to have many stars, of course. How do we have many stars? We could have an array or some kind of pointer, but I'm not ready for that. How do we model the stars? That's a good question. I completely forgot how to store those, how to store any application-wide variables, honestly. Maybe we should do it here somewhere. So we have, let's keep it very simple. We create an individual star, struct star, and that is our individual star, and that has coordinates 0, 0, 0. Or maybe we can keep it even simpler, guys. Maybe we can hack around the Z coordinate and just say we have an X and Y coordinate. Let me open Paint. Basically what we're doing is this. We have a black canvas, and then we have stars originating here in the middle of it. Then those stars are moving in some direction, and the closer they get to the edge of the application, the bigger they get. But also, but also the faster they get. And I think we don't have to model a Z coordinate. We can just check how far from center has the star moved and then accelerate it. And that possibly gives us this effect that I was talking about. That one, because here the stars in the center of the screen move slowly, and the closer they get to the edge, the faster they are. Although here it is a bit different. There are also stars in the background, which are still quite small and still quite slow. So probably this is a real... probably this is a bit more realistically modeled. Or to get this feeling of depth, maybe we can have random initial widths of the stars. So some stars might start big, so they appear to be in the foreground and they end even bigger. But sometimes some stars might start slow, like this one, and grow more slowly. And this might, I would be very curious how that looks like. Let's try to model stars as just two-dimensional points. Maybe this is not the correct approach, but this is an interesting approach that I would like to see the result of. And I'm going to make the X and Y coordinates doubles because we're going to perform some calculations with it, probably some division, and we want to keep the accuracy. So something that we can do as a first experiment here is we can try to generate, let's say, 1,000 stars in an array and all have them move towards the edge of the screen, or at least, let's keep it very simple. Let's generate 1,000 stars. Let's generate 1 star. I mean, we have to start somewhere. So this is our star. And in the move stars method, we pass as an input a pointer to the star. That pointer does not yet exist. So let's create it. Struct star p star is equal to the address of star. Okay, so here we have this star, and in move stars, what we do is we accept as input a star pointer p star. Oh, and we must say that it's our own struct here. And okay. And then we visualize the coordinates of that star by calling p star arrow operator to access the fields of a pointer. X, p star y, and let's, okay, there's the application now, and the star has coordinates 0, 0, so of course it's there, it's rendered there. Now I would like the coordinate system of our application to originate in the center of the screen. So that's going to look something like this. This is the center of the screen. Let me use a thinner brush here. Oh my god. Guys, I know I'm extremely slow. And many people probably are angry about the slow pace of those videos, but somehow that's how I work, and somehow magically at work or in private projects or at university and all those places, despite working slowly, somehow I'm able to make very good progress. Because I think working slowly is something that is very underestimated. Yeah. So we are going to generate a coordinate system. We are originating our coordinate system now in the center of the screen right here. That means I want a star with the coordinates x equals 0 and y equals 0 to be rendered at the center of the screen. Okay, so first thing that we do is we apply our width and height coordinates to the create window command, which we forgot earlier. Now we have a bigger animation screen thing here. Let me just also initialize the application a bit off center, and that's just such that for the video's sake, the application, I don't have to move it here anywhere always, because I don't like if it's overlapping the video, the webcam. Let's do. What happens if I do that? That's too much. And the window position here we can do minus 150 probably. Let's see. No. I think this is something that should not be tampered with. Oh my god, I'm doing rookie's mistakes here. The window position center is going to be probably resolving to -1 or some constant like this. So doing arithmetic with it is not working, of course. No, let's forget about that. This is fine. All right, so now we are rendering this one single star that we have on the screen. Now I would like to render this at the center of the screen, even though its coordinate is 0. So we subtract, or we offset the SDL coordinate system. Let's say this is the window pane. The SDL coordinate system starts here. This is the Y coordinate, and this right here is the X coordinate. Okay, and I would like to move that coordinate system into the center of the surface right here. I don't like that color right here. And to do that, we can add on top of all Y coordinates, we can add the height divided by 2, and on top of the X coordinates we can add the width divided by 2. So quite simple. So let's do that. X width divided by 2 and Y plus height divided by 2. Let's execute that, and there we go. The star is approximately at the center of the screen. Of course, we haven't accounted for the width and height of the rectangle itself. And the bigger the rectangle is, of course, the more off it looks. But for a smaller rectangle, it doesn't really make a difference. So that is good enough. That is our first star. And I think let's start with an initial size of 10 pixels by 10 pixels. And that is our small star. Very good. Now I would like to move the stars somehow. How do we determine how the stars move? The star must have some velocity. Oh. It must have a Vx or delta x. Let's call it Vx, velocity x direction, and Vy. That model how fast it is moving toward a specific edge. And then it must have no, okay, that's good enough for now. I was already thinking about how to grow the star in size over time, but let's forget about that, and let's give that first test star a Vx of 1 and a Vy of 1 as well. Then in the move stars method, we can do the following. We render the rectangle, but before that we move it. So P star x equals P star x plus P star Vx. So that is how we're moving it constantly. Let's just, yeah, so now it's moving in x direction slowly, but it already looks good. I just love when things work and just when they move on screen. Let me just create the same line for the y coordinate. Oh. Okay. Yeah, now it's moving diagonally, which is good. And then we also have to update the velocities. P star. because the closer the star gets, the faster it is going, the faster it will move. So let's update Vx and increment it by P star let's just say +1. +1 is fine. Of course, we will probably find a better solution. Oops, and there it goes. It looked very, very laggy. Probably +1 is way too much. +0.1. How about that? Oh, it doesn't look very, very smooth somehow. Let me just reduce the SDL delay to 5 milliseconds only. Ugh. And let's reduce the acceleration to something very small. That's smooth, but it looked very unnatural. And probably the Vx, the choice of 1 is way too high, because stars don't move that fast. 0.1, and this one is also 0.1. Ah, no, somehow something is wrong. Let's just experiment. Let's say Vx is equal to P star. Maybe it's proportional to the x coordinate. Yeah, how about that? How about that? Oh, that was way too fast. Of course, we have to divide it with some factor. Okay, it moves slowly now. Very slowly. And that is, of course, too slow. What could we do? How does the star move in the x direction? So, the closer it is to the edge of the screen, the faster it should go, obviously. But how do we realize that? How do we make this happen realistically? We have to determine the position offset by width divided by 2. So this is now the position from the distance from center, the x distance from center, and depending on the distance from center, let's just do that. The distance from center, depending on the distance from center, let's just do +1 so that it is not stuck at 0. Let's see what happens. Nothing, of course. Oh, God. No. This is the distance from center because we're already dealing with the star coordinate system here. P star x. P star Vx is equal to the x position divided by 100. Let's try that. That looked good actually. Let's do the same for the y coordinate. Vy, and let's see what happens. Of course, nothing happens. Oh, something happens. Maybe that was okay. Why not? I think the problem is that when a star is exactly at the origin of a coordinate system, and I mean x equals 0 and y equals 0, then even in practice, if you're in a spaceship and you're moving exactly at this star, then it's not going to change the position relative to the coordinate system. It's just growing bigger. For example, let me illustrate that with the webcam. What is a star? This thing right here is a star. So this thing right here is a star. Now, if it's off the screen and I move straight at the webcam, you will see that it moves to the side of the 2D image. Something like that. But if I move exactly from the center of the screen at the camera, then it will stay at the center of the screen, and that is what's happening in the video right now. All right. So let's see what happens if we make the star originate at a coordinate, for example, 5 or something like that. Yeah, why not? Why not? That is quite nice. That is quite nice. I think we can try to now generate multiple stars. So now we have stars. We have a move stars method. I don't know if it works for realistically for multiple stars, but let's try something. So this right here is our star. Let's create a struct star array with 1,000 stars, or let's do 10 stars. Star array. Oh, I forgot how to do arrays in C. C create array. I have to declare the array and then add elements. But how was it declared? Struct stars size. Maybe let's just like this. Maybe let's do it like this. Stars, and that is an array of size 10. And let's generate stars. For int I equals 0, I smaller than 10, I plus plus. So let's loop over the 10 stars. Don't worry, we'll use variables soon. Or let's do it immediately. Let's define star count, and currently it's 10. Star count and star count. So let's do the following. Stars at element I is equal to stars at element I is going to be equal to an x coordinate. What is the x coordinate? We have to generate random numbers. Double x initialize, or initial x, is going to be a random number. Let me just look up how to generate random numbers again. C random number double, ideally double. Okay. Okay, we can use the rand function together with a modulo operator, and the rand function is defined in standard lib. So let's include standard lib .h, and then initialize x at rand modulo. I want it to be a number between 0 and 5 maybe. 0 and 5, and it's going to be a double. Oops. X init. Let's just call it X. I think it's obvious that it's the initial X. What is the issue now? I don't get what the issue is here. I'm declaring an array stars of star count, and then I'm looping over the star count and then trying to set the array elements to stars at index I. Now there maybe something like that. No, this can't be it. Did I miss something? Let me try to compile it and see the error message. Expected expression before parentheses, before the curly brace. Why? Am I stupid? The stars is defined here. C array of structs. It's interesting that you can see by the color highlighting here that I've already read all of those search results that I'm looking up today, but I forgot all of it. Array of structures in C. Struct A array. I don't get what the issue is. I'm looking up the most stupid stuff possible. Probably. Define the struct name, all of that is fine. We have members on the struct on our star structure. Then we are declaring an array of struct star, stars, struct star count. There is no issue with this code. It's completely fine. X, Y, that is Vx, and that is Vy. Okay, I give up. Let me look up that error code here, or that error message rather. I sincerely feel stupid because I don't know how I've done it before. Double X, double Y, double Vx, double Vy. But I don't have to cast them to doubles because they are already defined as doubles. Wait, let me just naively put numbers again. Does it make a difference? Oops. Does it make a difference? No. Do I have to cast? I think maybe I have to cast. Why? Why do I have to cast? Why do I have to cast it? Oh my god. Okay, we still have that one single star because we're not using those stars, but apparently that is the solution for the problem. I don't know why this is necessary, honestly, but okay, if it works, it works. Then now we have a stars array, and let's where can we use that stars array? We can pass it to the move stars method. And in move stars, we expect a structure star array pointer star what star pointer P star, and that is an array? No? Star count? Maybe something like that. And then we loop over the stars for and I equals 0, I smaller than star count, I plus plus. We do the following. We render all the stars and update their states. And here in this case, P star is equal to the provided P star array at int I, and we take the address of that. Does that work? No. So we are passing a pointer to an array here. Struct star pointer to an array. Stars. And of course that array has to be called stars because it's multiple stars and to not conflict with the existing variables. And then we locally create this struct star pointer P star maybe this works. I don't know if I have to use the ampersand here. Probably I have to use it. We're passing a pointer to an array. So I probably have to destructure this pointer. Dereference. Or can I just do this? Let's just execute it and see what happens. Okay, it doesn't work. Expected struct star, but argument is of type struct star pointer. Expected struct star pointer pointer. Why? Struct star. How about we just pass the array as such? No complications here. Stars. I done. Fine. Good. And then this is just a simple star. And here in this code, we replace all occurrences of P star with star. Why didn't that work? We replace P star with star. No idea. Then let's look for P star. And replace all of that manually. And of course the arrow operators are also wrong. So let's search for arrow. And whenever we find one, we replace it with a dot, just like that. Let's repeat that a couple more times. And that's it. Let's see. Still something wrong. Expected struct star pointer, but argument is of type struct star pointer. So we're passing something incompatible into the method, of course, because earlier we referred to ampersand stars, so we used the address of the stars, but now we can just copy the stars into that application. I think using the pointer is probably the faster way, but as my C skills are totally dried up, I'm just going to go the easy route in this video. Star. There's a typo somewhere. Star. Yeah, of course. And that doesn't work because we are... Why does this not work? Oops, what's that? How did I do that? Can I zoom in again? Okay. So this is now the first star that was generated apparently. Why is it not moving? I don't get it. Ah, of course, that's because in stars we construct the stars without the calculated values here, without the generated values. So let's do that. Vy and try that. And we have a couple of stars, that's good. We can see a slight overlap of rectangles there, but they are not moving. And I have no idea why they are not moving. I think maybe we have to use array pointer operations here to change the actual value in the star's structure. So here we are copying the structure star into the method. But that doesn't change the actual values inside that because we're working on a copy. So let's do a pointer. Pointer. This returns a star. I don't know if I probably also have to use the address here again. And that crashed. Awesome. Do I really need to pass a pointer to an array? I can just pass a pointer to the first element and then call p stars maybe at index I without an array. That seems to work, but still we're not changing the actual contents of the structure in memory somehow. Structure star pointer stars. Stars are initialized down here. And provided to this method. That is fine. What if I do this and change this to arrays again? Arrows. Let's see. Let's save that, go back to the code that we just changed. There's an error already here. Star is undeclared, of course, because now we have to do p star, because this is a pointer. And this is the convention to name pointers. Star. Okay. And now something's happening. Yes! Awesome. Although we have an error message in in the code. Not in the code, but in here, in the compilation thing. What's the error here? Passing argument 2 of move stars from incompatible pointer type. What's incompatible here? I think, did this just work by accident now? This is already an array, and an array is a pointer, and we're expecting a pointer in this method. So we can just provide the array. Okay, at least something seems to work. And all the stars are moving in the same direction, roughly, in positive X and positive Y direction, which is not what I want, of course. And that is because I have to let's generate a positive number between 0 and 10 and then offset this by -5 so that we have positive 5 to -5 values. And no, this doesn't work. We have to generate a number between 0 and 5 and then do No, this will work. 0, 10, and then subtract 5. Then we get numbers from... I don't get it. Then we get numbers from -5 up to 5. Okay, let's just try that and see if it works. I think this is one of my favorite sentences on this channel. Let's just try and see if it works. I've said this so many times already. Okay. Oh, it looks good. Looks really good. Okay. Then I think we can just set the star count to 1000 and see what happens. And of course I just mistyped something somewhere. So let's undo all of that, and now let's do 1000 stars and execute. Oh, what? Why are they so regular? There's no randomness in there. Where's the randomness? Okay, but at least this zoom animation somehow seems to work. Where's the randomness? So everything is moving entirely uniform. Probably we have to... Yeah, the problem is that here it's only possible to generate numbers between -5 and 5 flat. So we actually generate integer numbers here, but I would like to have real double values. So we have to look up how to generate random double values. See random double between 0 and 1. Or -1 and 1, it's also fine. Rand max, we have, okay, that is fine. We can use rand max to scale it. Yeah. Okay, so random generates a number between rand max 0 and rand max, and then we can use that result. And we can divide by rand max, so we have something between 0 and 1. And then we offset this with... We multiply by 5, so we have between 0 and 5. Let's do 0 and 10, and then we offset by 5, such that we get random numbers between -5 and 5. Let's see. Good God. Divided by rand max. Do I possibly have to specify that rand returns a double? Somehow, such that this calculation is correct. Maybe. Yeah, let's just leave out the calculation for y. This looks okay. Yes, the stars were distributed equally among x, or what seemed like random numbers. Rand divided by rand max multiplied by 10 minus 5. Okay, let's see. This looks good. Very, very good. And now the speeds also need to be randomized a bit better. Double rand divided by rand max multiplied by 1 minus 0.5. And same thing here. So we can probably just copy this entire thing and paste it here. And now we should have a roughly random distribution, which is good. Let's make the stars a bit smaller. Yeah, right now they are 10 by 10. Which is too big if we have a lot of stars. Let's do 2 pixels by 2 pixels. This looks really nice. This is good, very good. And now the problem is that we have an entire wall of stars coming. Oh, sorry, an entire wall of stars coming at us, but no new stars are generated. How do we do that? This will necessitate somehow removing stars from the array if they have exited the screen. So we can do an inefficient second loop here. So here we draw all the stars. Okay, that's fine. But let's do I know this is inefficient. We could probably do all of that in the same loop. But let's do an inefficient second loop. And here we check if p star x is bigger than width, which means, or is bigger than, no. How do we know if the star has exited the screen? We have to know the absolute value of the x coordinate. C math absolute, not x, c. There's the abs function which we can use. Oh, we don't even need the math library for that. So how far is the star from screen? We do the following: if the absolute value of p star x is bigger than half the screen width, and the absolute value of p star y is bigger than half the screen height. And if that is the case, forget, then the star left the screen. Forget star and generate a new one in its place. Okay, so what do? We access p stars at index I, and this is going to be a new star. Okay, and for this we can generate a new method to generate a new star that returns a struct star. New star. And this method returns or generates a new star using this logic down here. So we can just remove all of that. Also call new star from this. I think we need to copy this part, which is the logic, and then let's just paste it first. So this is the logic, and then down here I can return this. Return this. Let's indent this properly, like that. So this generates a new star. I hope it's usable. And then down here we call new star. So this is the initial star generation. And then here what we do, we generate new stars. Okay. Let's see what happens if we execute the application. Okay, yeah, yes, we have. Okay, that looks good. That looks very good. It looks surprisingly good. Oh, it looks very good. It's very interesting that the animation starts with stars. It's very interesting that the animation starts with two walls of stars coming in, but that is because the stars have to first gather the randomness to be generated at truly random times. And at first we have this one star, this one wall of stars pre-generated, and then almost all of them hit at the same time, exit the screen at the same time, and then the second wall comes in, and after the second wall we have enough randomness for the animation to look like this. But this is already very, very good. Now, what I dislike is that all the stars originate here on the screen, in the center of the screen, but we can solve that by editing the new star method. And am I stupid? New star. There it is. And here the issue is that the X and Y coordinates start, they are limited to -5 to 5. Let's increase that to 100, to 50 to -50. So let's just do that. Yeah, let's just do that and see what happens. This is our first wall of stars. This is the second wall of stars. And now we have stars being generated. This looks nice, although I think everything moves too fast, and I dislike that we can't see the generation of new stars in the middle of the screen. For that, and I know we could work around those two initial walls by generating the stars truly randomly across the screen. Well, what happens if we do that? Why don't we do that? Let's try it and see what happens. Oh, that's nice. Why not? It's a bit fast. How do we work around that? I think I would like to define a speed. And that speed is set to 0.01. And then we use that speed variable to offset or to manipulate all the speed variables. And of course, we offset also the delay. Let's see what that does. Okay, that is now incredibly fast, probably because the delay is now very, very small. Okay, this looks smooth. Maybe still a hint too fast. This is very slow. And I'm missing the depth now of the star field. That is... I'm missing the depth. What happens if we define 10,000 stars? Okay, that is way too much. Let's do 1,000. Let's do 2,000 stars. Each star starts at the stars should start somewhere in the middle of the screen, I think. So let's limit that again, because I think if the star is generated at the edge of the screen, there's no benefit to generating it at all, because it doesn't have its journey across the screen. So let's try multiplied by 200 minus 100 maybe. Multiplied by 200 minus 100. And let's execute this. This is our first wall of stars. And after that first wall, we should see some more depth. I don't like that we see the stars popping up there. But still, it looks good. It looks good overall. Now, probably one thing to give it a better effect, a way better effect, is to give each star a distinct speed and a way more variable speed. So right now the speed is varying from 1 to no, from minus 0.5 to plus 0.5, which is way too little probably. So let's try to do minus 5 to plus 5 and see how that looks like. Here's the first wall. Hey, let me just also check how the speed is updated. Everything appears to be very uniform. So we update the x variable depending on the speed, obviously, but we update the speed depending on the x variable, which normalizes all the speeds again. But the speed should be proportional also to the initial speed, probably. So maybe we can change something here. P star Vx is, what happens if we just keep the initial speed? Okay, that's interesting. That's a constant movement of stars. It looks quite circular. What happens if we do Vx plus or multiplied by what makes a star move fast in x direction or move slowly? Oops. What happens if we multiply by x? Let's just see. Let's just experiment with different math. P star x. This will be way too fast, of course, because this is a pixel value. Multiply by x divided by 100. Ooh, that's very interesting. But of course, this is wrong. P star x plus 1. What was that? Okay, no, the speed being proportional to the pixel position is fine, but still I would like to have some stars, some individual stars moving fast along a specific axis, and probably we can use some speed factor for each star. That determines that some stars are just far away and therefore slow, and some stars are closer and therefore fast. So we can do, in the new star, generate a new speed factor that is a random number divided by rand max, multiplied by, let's say it is something from 0 to 1 is fine actually, so we can leave it as is, and then we can add that speed factor here, and of course I missed the equals sign. Yeah, experienced engineer of course misses the equals sign. Then next step down here where we generate the initial stars. that uses the same method, obviously. Let's see, with the speed factor, everything should still look the same. Yes, everything moves uniform, but some stars should move faster now, and we can add this with the individual stars speed factor. The Vx. Okay, this determines the velocity, the physical velocity of the star, but the star should be moved on screen according to the speed factor. Or some things here really feel off, but let's just get it working. Speed factor, or P star speed. No, let's add the speed factor in the Vx thing. P star speed factor multiplied with that, and then let's add the same change here and execute. Oh, and that's good. That's what I would expect. So some stars move fast, and this gives us the three-dimensional effect, and some other stars are incredibly slow. This now looks exactly as I wished it to look like. And I think also what we should do is, according to the speed factor, which determines how close a star is and therefore how fast it moves past us, according to this speed factor, we should scale the size of the star. So low speed means far away, small size, and high speed means close, therefore bigger size. We can do that where we, in the place of code where we generate the rectangle. And these two variables here, the two are the width and height of the star, as it is represented graphically on the screen. And here we can say speed factor multiplied by, and the speed factor is a value between 0 and 1. So let's make the small stars a pixel size of 5. The big stars a pixel stars a size of 5, and the small stars a pixel size of 0. I'm having a really hard time speaking while I'm thinking, so please excuse me, but I think I have good expectations now of this. So I want this to become an integer after it is calculated, of course. And this has to, maybe I don't have to cast it. The issue is just that I need to refer to the field in the structure. P star. Okay. Let's go. And there we go. So this looks really good. Although it is not quite there yet. Because I also think that the stars should scale, they should not spawn as bigger stars directly on the screen. How do we do that? Rectangle, speed factor. The star should also be small if it's... Oh. Yeah. If it's closer to the origin of the coordinate system. Let's just do something stupid. Let's just create a variable that is double distance to origin, and that is the square root, of course. C math distance. Oh my god, my internet is gone. So we have to do without. Great. Square root of power of p star x minus width divided by 2 to the power of 2 minus or plus power p star x p star y minus height divided by 2 to the power of 2. And let's see if that works. A semicolon. And then here the width of the rectangle, oops, should be scaled according to that distance to origin as well. So let's see. Distance to origin multiplied with this. I'm also mixing up camel case with the underscore notations. Please excuse me. Distance to origin. Let's see if that works. Okay, there's an error somewhere. Undefined reference to symbol square root, of course. And I think that is because I am not compiling with the math library linked. So I can do -lm. And then I have to include math.h up here. So let's try that again. Somehow the -lm went missing, and that is definitely not it. Distance to origin is power of p star x minus width divided by 2 to the power of 2 plus power of p star y minus height divided by 2 to the power of 2 and square root of that. That is fine. Let's print f that number, just so I know what it is. Okay, it's always something very big somehow. I'm stupid. Of course, I don't have to offset by the screen width and height, because we're already working in the star coordinate system that is already offset. Okay. So now the distance to origin, let's factor that also and make it very, very small. Let's make this a very small factor in this calculation and see if we still get a successful animation. No, we don't. These values are still somehow very big. But I think it is correct. The distance to origin is correct, I think. Maybe that approach is entirely stupid and I'm not seeing something which I should see. Let's just remove all of that again and see if the application works again. This looks good. There are some small stars generated and some big stars generated, which is fine. Oh, actually it's fine. Actually it's fine. Let me remove that print statement and let's set the speed to something larger. That is way too slow. I have no idea why it is slow now. This works. How about 1000 stars and make it a bit faster? No idea. Ah, small speed is faster. Okay, that looks good. Let's make it 0.5. Okay, and let's just try one more thing. And that is the speed factor can be it would be very nice to have a few stars that are very big, but most of them are far away. That is something the speed factor, which also resembles the distance, does not really account for. I think this would require some normal distribution of values, but for that I don't have the internet access right now to look that up. It's always great that my internet crashes down when I need to research stuff. And yeah, so the speed factor, we can scale that probably. Right now it's a number between 0 and 1. Where is it even? Where is the speed factor calculated? Did I just delete it? Ah, no, it's up here. Okay, it's a value between 0 and 1. Let's make it a value between 0 and 2. Yeah, why not? Why not? It's fine. Why not? Let's make this run a... Let's just try this speed. Maybe the speed factor needs to be a bit smaller. Somehow I dislike the size of some of the planets or stars. Oh, that is good. That is what I wanted. Yes, that looks really, really fine-grained probably on screen right now. So for the recording and because of video compression, it will look not as good as what I see on the screen right now. But this is now a really three-dimensionally looking Starfield. This is awesome. This is what I wanted. So this is what we need. I think I have to make it a bit bigger again, just so you can see it better. But I think this is an awesome Starfield. So this is the application that we built in this video series, or no, this was not a series, it was a single video. I spent my entire morning developing this, and I hope that you like this. That's an awesome application. I did everything from scratch, looking up how to create arrays in C, how to do the smallest details in C, because I already forgot all of that stuff. And if you enjoyed this video, then please support this channel. There's a Patreon also, and any comment, any like, any subscription would be very well appreciated. This just looks beautiful. Awesome. See you next time. Bye.